So today we're going to be looking at some pre-calculus, law of sines and cosines, aka section 8.1. So let's see, I set up a problem here. If you want to pause the video, try to set it up, go ahead. If not, I'm going to dive right in. So you'll see we have to solve for the sides and angles of a triangle. I made a little rough sketch on the right here. And for convention, throughout this video, I might mention a set. And by a set, I mean if we have an angle and its corresponding side, I would call that a set of values, or set of B values, set of A values, whatever you want to call it. So looking at this particular problem, you'll see we have an angle for angle B, side A, and side C. And looking at our law of sines, you'll notice that to use the law of sines, we need at least one set of values. Two A values, B, two B's values, a set of C values, whatever it is. So in this case, if you see a problem with no sets of anything, we're going to have to go right to law of cosines. And the reason I picked this problem is because we're going to have to use both, but we're going to have to start out with the law of cosines. So to use the law of cosines, we'll see I set up one of the variations of the law of cosines, but if you have one, you can find the others. So this one will be based on the cosine of A, but we don't have the cosine of A, or the angle A. Here we have the angle B. So we're going to rewrite this. We're going to try to copy down the alternative form of the law of cosine so that we can use the cosine of B in our side A and C. And that's going to look a little bit something like B squared equal to A squared plus C squared minus 2AC cosine B. And the reason why I can go from one to the other is you'll notice a little bit of pattern here. If we have the cosine of an angle, we'll be solving for its corresponding side, squared. And then the other two sides will appear before the cosine, and they'll appear as squared values in front of it. So from here, we can plug in, solve for B. And that's going to look something like B squared is equal to 2 squared, which is 4, plus 4 squared, which is 16, minus 2 times 4 would also be 16, cosine of the angle B, which is 70 degrees. Plugging this in, we can then solve for B. I'm going to simplify this a little bit more. So B squared would be equal to 20 minus 16 cosine 70. Make sure when you're plugging this into your calculator using degrees. This is in degrees. Don't make simple mistakes. So solving for this, we would find that B is equal to 3.812. And I didn't copy it down. Oh, I did. So round to the nearest 1,000th. So we go to the 3 decimal places. Remember that this is 10th, 100th, 1000th. So we're going to 3 decimal places. All right, so now that we've found our side B, we now have a set. We have a angle B and we have a side B. So now we can go to our law of sines with this set we've just created. So I'm going to move to a new page. I'm going to copy down that law of sines, which was sine A over A equals sine B. B equals sine lowercase b over sine C over C. All right, so since we have the set of B values, I'm going to set it up with that up front. So we'll have sine of 70 over 3.812. That was the B value we just solved for. That's going to be equal to sine of A, angle A, we're not sure what that is yet, over 2, its corresponding side length, which is also equal to sine C over its corresponding side length, which is 4. So I'm going to break this up, solve for them separately. So this means looking at just the sine A over 2, multiplied by 2 on both sides, we end up with sine A is equal to 2 sine 70 over 3.812. And that, remember to solve for 2 sine 70. Actually, I'll do that right now. 2 sine 70 divided by 3.812 will give us 0.493. Remember to keep it to that 3 decimal places, so we maintain accuracy. And then at this point, to get the actual angle for A, we're going to have to do the arc sine of this value. 0.493 spits out an angle A of 29.539 degrees. All right, now do the same thing, exact procedure for C. I'm going to move to another page. So for C, we had sine of 70 over 3.812 equal to sine C over corresponding side length, which is 4. So again, now we're multiplying by 4 on both sides, so we end up with sine C is equal to 4 sine 70 over 3.812. Solving for this, we end up with 0.986. And again, just like the last time, to find the actual value of the angle C, we have to do the arc sine of this 0.986, which gives us 80.414. So to put this all together, we have B here was 3.812. Our angle A was 29.539 degrees. And our angle C was 80.414. So looking at this, I'm going to draw another sketch of this triangle, and I'm going to put our actual values in now. Sorry for the rough sketch. So in this case, our angle A here is 29.539. Our angle C is 80. I'm not going to put all the decimal places, just get a general idea. Our angle B was given at 70. Side B we found to be 3.8, side A was 2, and side C was 4. Now if you notice, the largest angle here, 80 degrees, is paired up with the largest side. Its corresponding side length is the longest side on this triangle. And conversely, our smallest angle, this 29.5 blah blah blah, has the smallest corresponding side length. And to keep going with this, our angle in the middle, I guess, has the middle side length. So you see that the angle and the sides would correspond. So if you're getting values that don't agree with this, you might want to go back and check your work.